And I think I've described to you guys before when I write a test and how we're instructed to do it from SACE is we have 70% routine marks, so they're the skills that you've mastered now, and then 30% of the marks should come from what we call complex higher order thinking skills. And that's the skills that we're going to develop here. And so my expectation wouldn't be that you can go ahead and solve this problem straight away, okay, unless you're a genius. So a challenge for somebody out. However, once you've shown a bit and once you've sort of wrestled with them a bit and developed a bit of skills, then this kind of thing is appropriate for us to ask you in the test. So what we're going to do, whenever we have a problem like this, we're presented with different pieces of information that we need to use. And this is like a 5-mark question. So we need to try and get, in a test situation, try and get as many marks as we can. So we're looking at this, we're going, how can I get as many marks as possible? So the first thing we want to do is use the information that we've got given. We've got when x is 3, the y value is 1, and the slope is -1 on 8. And the question wants us to find the values of a and b. What are the values of a and b that make this true? So let's use this piece of information first. So I'm going to put 1 where the y is, and I'm going to put 3 where the x is. Okay, that's our first statement. Alright, I've got when x is 3, y is 1, I put 1 where the y is and I put 3 where the x is. And we can rearrange this a little bit. I'm going to multiply both sides by this denominator. I'm going to move it up there. That's what I'm effectively doing. The square root of 1 plus 3b is equal to a. So we've got 2 variables and I've already managed to isolate one of them. I've isolated a by itself for us to solve. Okay? And so we've used the first piece of information. Alright, so now we should be looking to use the second piece of information. We've got when x is 3, the derivative is -1 on 8. Now in order to use that, we need the derivative function. So this is our function, it's a times 1 plus bx to the power of a half. And we're going to differentiate that using the chain rule. Alright, a and b are just numbers. It works, the rules work just as if they were numbers. So we'll go dy on dx a is just going to hang out. Alright, and so I've got 1 f of x to the power of n. F of x to the power of n. This is my chain rule. N f of x, n take 1. And then multiplied by f dash of x. Derivative of bx, b. Derivative of kx, k. That's what we expect. Okay, so that is our derivative function. Now, sorry, I have made one mistake. This power should be negative, shouldn't it? Negative half, so then that's going to be -3 on 2. Alright, let's simplify this. Just like when we have to put x and y values in, we should be looking to express that back as a fraction and in terms of a surd and so forth. So at the top, I've got a and b. A times b at the top, and it's negative. So I've got negative ab at the top. At the bottom, I've got 2 times 1 plus b of x to the power of 3 on 2. And remember, when anything's to the power of 3 on 2, like if I had n to the power of 3 on 2, it means n times the square root of n. So that means at the bottom, I have 1 plus bx to the power of 3 on 2. It's going to be 1 plus bx times the square root of 1 plus bx. Okay? So we can express it in terms of surds and fractions. Okay, so let's break down. I said we want to get as many marks as we can. We've used this piece of information. We've got 1 mark. We've found the derivative. That's given us a 2nd mark. Now we need to use the second piece of information, which is when x is 3, the slope is -1 on 8. So remember, this is the derivative function here. So I'm going to put -1 on 8 where my derivative is, and I'm going to put 3 where the x is. so now we've used that piece of information. And now what we have is we have two equations. We've got this equation involving A and this equation involving A and B, and we want to synthesize them together somehow. We want to bring them together with some substitution in order to break down the variables. And so hopefully we can see I've only got one lot of A there, so I'm going to replace A with this square root of 1 plus 3B. All right, so I'm going to restate this, but with A as the square root of 1 plus 3B. Okay, we've got something in common that can cancel. We have the square root of 1 plus 3b at the top and the bottom as a product, so we can get rid of that component. Okay, I'll come up here with what we've got left over. We've got minus 1 on 8 on the left-hand side, and we've got minus b on top of 2 times 1 plus 3b on the right-hand side. We've got the negative on both sides, so we can get rid of the negative. All right, and now if you're looking at this, if you're looking at what we've done, we've broken it down in such a way that we've only got b. We've only got one variable. This is a linear equation. We can solve through for b. So I'm going to cross multiply the denominators here. I'm going to move that one up there, and I'm going to move that one up there. And so we'll have 2 times 1 plus 3b is equal to 8b. All right, divide both sides by 2. And subtract 3b from both sides. Okay, we have b equals 1. We've found one of the variables. Here we have an equation for a. We're going to plug the b value in there. A is the square root of 4, positive or negative 2. So that's a beautiful question, and it does pop up. I think it's probably in 3 of the past 7 tests. So I'll just, again, emphasize, what are we doing? Like, I don't expect you to be able to go home and do that straight away. It's something that we practice and that we wrestle with. Get the marks, okay? So start with the equation, use the information you give, okay? There's 1 mark there, all right? Rearranging to get A. Next, what do we do? All right, we need to use the second piece of information. In order to use that, we have to differentiate it. So we'll go through, differentiate it, plug in that information, okay? Plug in that information. Raj, then we can sub in the A. We need to combine them somehow. So right there, we're at 3 marks. When we combine it, that's our 4th mark. And then we're processing to get B and A for our 5th, maybe 6 marks there. So that's like a good indication of how hard Year 12 methods get. So that's probably as hard as it does get. So as long as you can follow along, you'll be absolutely fine. Anyone get lost anywhere or any questions about the process there?
Not one.
Good, we've got 6 minutes left. I'll just say one other thing about question 4. In question 4, you're substituting those numbers in. So you just process it as best as you can, and I don't want you to get bogged down spending half an hour trying to get that exact right answer. All we're looking for is find the derivative, put the number in, and process it. Okay? There will be one in the test, so you are required to do a little bit of manual math. You won't have your calculator, so develop that skill. Now with this exercise, we've skipped question 1 and 2. We've done question 3. I think most people are sort of on to question 4. 5, 6, 7, 8, I'm going to set as, we've done question 6, so you can try that again, but 5, 6, 7, 8 I'll say are sort of optional extension. Both 5 and 6 have appeared in tests before. 7 and 8 aren't because they're both too hard. 8's even a little bit abstract. Back at 2C.1, you're welcome to do all of that. That's just, I think we're pretty comfortable there. Those are sort of Year 11 skills. So that's where we're at with 2C.2. Well done. So we'll do some product rule on Tuesday.